So, to start the lesson, I want you to convert each of these angle measurements to radians. So pause the video, write these down, and convert them to radians using your toolkit. So, here's my answers. Check them with yours. So basically what we're doing is we're multiplying each of them by 2 pi over 360, and then you're reducing this fraction here. 200 divided 40 divided by 360 reduces to 2/3. So check your work, and let's move on. Next, I want you to convert each of these angle measurements to degrees. So using your toolkit we took last week, we're going to do pi times, and here we do 360 divided by 2 pi. So that's how you start all these. Pause the video, convert them, and then check back in when you're done. All right, here's the answers I have. Check your work with mine. And if you're all good, let's move on. So to start this lesson, we first got to learn about coterminal angles. So if you think of some words that start with cooperative, that means together. And so they're angles that are the same. They have the same point. So if we want an angle that is coterminal with 45 degrees, so it's important to note that any angle, or 0 is always starting on the right. And so 45 degrees, we draw this line, goes to right there. And we want another angle that's going to end up at this point. So the way we do it is we think, okay, well, that's going forwards. This way is moving positive on the unit circle. What if we go backwards? How many degrees is that? So let's count by, I think 90s is a good one to start with. So if we go backwards, we go 90, 180, 270, and then you need this extra 45. So that was 270 plus 45, and that gets us 315. But going forwards is positive, so how could we show we're going backwards around the unit circle instead of forwards? Well, we make that 315 negative. So negative 315, going backwards 315 degrees, is the same as going forwards 45. So what I want, let's move that with my own hand. So what I want you to try is find an angle that is coterminal with those 4 over there. So once again, pause the video and take a little bit of time to try to find angles that are coterminal with those. So here's my answers, and it's important to note that there are actually a bunch of answers here, because if I go 135 for the first one, I could go around the circle again, and I would end up back there eventually. So another answer for 135 would be, well, 135 plus another full spin would get us 495. That angle would also let us back up on that point. So there's an infinite amount of possibilities here, but just understanding that it's a circle and you can just go forwards or backwards is important. One thing I know one of you noticed at least is that, what do we notice about these two numbers here? What do we notice about 45 and 300, negative 315? 300 and negative 60, negative 150 and 210. Well, I know one of you might have seen it, and it's that 300 plus 60 adds to 360, so it makes a full circle. So that's one pattern you can use with these coterminal angles. So we also have coterminal angles with radians. So if you're not familiar with these radian measurements yet, you're going to need to memorize them. So it might be a good idea to study that a couple times throughout the day just so they become really familiar. So we need an angle that is coterminal with 5 pi over 4. So if we go to 5 pi over 4, right here, this angle from the center, this angle right here, an angle that's coterminal is if we go backwards. All right, so it's important to note that each of these green lines, each of those small ones is pi over 6. And each of these, I think it's red, I'm colorblind, but from the center to red, each eighth of a circle is pi over 2, or pi over 4, sorry. So we see that this is going to be with one of the reds. So I'm going to count by pi over 4. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's how we're finding angles that are coterminal. So I like to just count 1, 2, 3, 4, 5, counting by pi over 4 or pi over 6. So an example, another example would be, let's do this pi over 6 one over here. So we have, what angle is coterminal with pi over 6? So we're going to go backwards counting by pi over 6's. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. And these are both supposed to be negative. I apologize for forgetting that. But I want you to take some time to try to find angles that are coterminal with those. So here's my answers, and there's one good pattern you can use. If we're looking at 2 pi over 3, the easiest way, I think, a sort of trick to do that is you just look straight down. And it's not 4 pi over 3 as I made the mistake earlier. It's a negative of that angle. That's going to be your coterminal. So just a little trick to keep in mind. All right, so now we're going to get into sine and cosine. So what we're going to do is I have our triangles over here that are representing the two special triangles we're using to find these values we filled in our first lesson. Square root of 3 over 2, 1/2. You should have this unit circle in front of you, which will help you follow along if you can't quite read these. So what I'm going to do is I'm going to take this right triangle and I'm going to fit it into that space just like we did with our first lesson this week. And we're going to find, we want to know this angle 45 degrees, what is the sine of that angle? So if you remember back to Math 2, sine equals opposite over hypotenuse. It's the opposite side over the hypotenuse. So if we look at this triangle, this 45 degrees right here, the side opposite that is the square root of 2 over 2 divided by our hypotenuse in a unit circle. Unit means 1. Our hypotenuse is always 1. So the sine happens to be the square root of 2 over 2. And let's notate that the sine of 45 degrees is the square root of 2 over 2. So we're looking at these, and if we did another one, what about if we used our 30, 60, 90 triangle? So I'm going to move this one out the way, and let's do a different angle. Let's rotate this. How about this one right here? So I'm going to fit that in. Let's rotate a little bit. There you go. So that's fitting in right there, and we want to find the sine of that side. So if we want the sine of, and this time let's use our radian measure. So this is 2 pi over 3. Well, we're going to use opposite over hypotenuse. So opposite our angle right here, our opposite side is, and it disappeared from me, but this is the square root of 3 over 2. Square root of 3 over 2. And our hypotenuse here is 1. So the sine of 2 pi over 3 equals the square root of 3 divided by 2. So that's how we're using this unit circle in conjunction with sine. So we're going to do the same thing now, but we're going to flip to cosine. So now we're going to start with cosine. So if you remember, cosine is the adjacent over hypotenuse. So we're going to move our triangle, and I'm just going to pick an angle. Let's do this angle down here. So that angle down there, it's hard to read with everything going on, is we want to know what's the cosine of 5 pi over 4. So the cosine is the adjacent side. So adjacent to this angle is, and that's upside down, but it's the square root of 2 over 2. The hypotenuse is always 1. So the cosine of 5 pi over 4 equals the square root of 2 over 2. Now, we've got to look at this because it's not in the positive direction, because this is a unit circle. We're going in the negative direction. So since we're going backwards the square root of 2 over 2, we have to make this negative. So that's because this is negative here. So the cosine of 5 pi over 4 is the negative square root of 2 because we're going backwards. This is going backwards the square root of 2 over 2 units. Let's try one with our 3069 triangle. So we're going to move this one back out the way. And let's go with, let's flip this around. And let's say, what about this angle right here? So what about the angle? And that angle is, we want to know the cosine of, and that is 5 pi over 3. So our adjacent side here is 1/2. Now is it positive or negative? Well, it's positive because we're moving to the right on our number line. It's this one here. So it's a positive 1/2 divided by 1, which gets us the cosine is 1/2. So that's how we're using this unit circle with cosine and sine. So keep that unit circle handy because we're going to use it going forward. So what I want you to try to do, oh, I apologize. The first thing we're going to do is we're going to take some notes. So the cosine of any of these, any triangle we drew, the cosine is the x value of the coordinate. So what that means, if we want pi over 3, if we want to know the cosine of this angle right here, it would be 1/2. It's the x value of that coordinate. The cosine of 90 degrees is 0. The cosine of 0 degrees is 1. The cosine of 7 pi over 6 is negative square root of 3 over 2. It's the x value there. The sine is the y value of the coordinate. So the sine of pi over 3 would be the square root of 3 over 2. The sine of 90 would be 1. The reason that is because when we draw these triangles, the sine equals the opposite over hypotenuse. And our hypotenuse is always 1. So it's whatever the opposite side is our sine. Our cosine is adjacent over hypotenuse. So it's always this adjacent side, the x value. Now just be careful because when it's above here, the sine is positive. When it's below, the sine is negative. When it's to the right, cosine is positive. To the left, cosine is negative. So pause the video and find the sine of all 4 of those angles. Here's my answers. Check them with yours. Just remembering, all you need to look for is the y value of each of those angles. Let's try it with cosine. Pause the video. Try to find the cosine of these 4 angles. Restart it when you're ready. Here's my answers. Just keeping in mind the cosine is the x value of each point.